Welcome to the Architecture Corner.
Great to be here.
Today we're digging into a really interesting piece you brought up about a common API headache. What do you do when traffic just explodes, but maybe scaling up the usual way isn't feasible, or, well, just isn't the answer?
Yeah, exactly. It's this classic scenario. APIs are everywhere, but their dependencies could be compute, databases, maybe even third-party services you don't control. They become bottlenecks fast, especially under heavy load.
Right. And the first thought is always more servers, scale it.
Sure, that's the instinct. But sometimes the cost just skyrockets, or like you said, it doesn't even fix it because the real bottleneck is somewhere else, maybe that third party you rely on.
Okay, so this article we're looking at offers a different path. It gets clever about classifying requests, doesn't it?
It does. It breaks them down basically into queries where you need info now and commands. And within commands, there are ones where the client absolutely needs an immediate answer. And then, this is the key part, commands where the client can actually wait a bit.
Ah, okay. So that third type, command the client can wait. That's where this asynchronous pattern really shines.
That's the sweet spot. Exactly.
Mhm.
For those specific requests where an immediate synchronous reply isn't essential, you can do something pretty smart.
Which is?
You introduce a messaging queue. Think of it like a buffer, a waiting area sitting between your API endpoint and whatever system does the actual heavy lifting.
Okay. So how does that work mechanically?
It's actually quite elegant. An
Sure.
incoming request hits the API. If it's one of those can wait types, the API basically just says, okay, got it. Maybe gives back a tracking ID or something, and then immediately places the job onto this queue.
And the API is instantly free again?
Instantly. It's not stuck waiting for the database or the complex calculation or that slow external service. It frees up your API resources massively.
So you can handle more incoming requests without them piling up.
Right. And crucially, you then control how fast you pull jobs off that queue to process them. You can match it to what your backend systems can actually handle without needing that sudden expensive scale up.
That makes a lot of sense for managing load and cost. But okay, the trade-off. The client doesn't get the answer right away. How do they eventually find out the result? That seems important.
Definitely. And there are two main ways to handle that notification. The first is often called polling, or maybe let's phone home, as the article puts it. Simple idea.
Mm-hmm.
The API gives the client a unique ID up front,
Mm-hmm.
and the client just checks back periodically. Is it done yet? How about now? Using that ID. It's straightforward to implement, but, can be a bit chatty and maybe not super efficient if the client checks too often.
Right. Lots of "are we there yet" requests. What's the alternative?
An other main pattern is a callback. So when your service finishes the task, it actively reaches out to the client. It sends the result back to an endpoint the client provided earlier.
Okay, that sounds smoother for the user experience, probably.
Generally, yes. But the catch is, it adds complexity on your side, the service side. You need solid logic for handling potential failures. What if the client's endpoint is down when you try to call back?
Hmm.
You need retries, error handling, that kind of thing.
Makes sense. So how does this fit into the real world today? With lots of hybrid setups, some cloud, some on-prem maybe. Is this practical?
Oh, absolutely. It's actually quite practical, even in those mixed environments. Cloud providers often make this easier. Think about AWS API Gateway, for instance. It can integrate directly with SQS, their queuing service.
So the cloud service can handle the queuing part automatically?
Pretty much. You can configure it so the API gateway just takes a request and puts it straight onto an SQS queue. Your backend service, even if it's not fully cloud native, just needs to pull messages from that queue and process them. It makes the pattern really accessible.
Interesting. So it's less about a massive overhaul and more tactical.
Exactly.
Yeah.
That's the key insight. This isn't necessarily about re-architecting everything from the ground up. It's a tactical move. You get immediate benefits, especially if you have, say, older systems or a mix of things. You're trading that instant response for much better stability and cost control under pressure.
A smart trade-off in the right circumstances. It really makes you think, for you, the listener, where in your own digital life is a delayed response totally fine, and where is it just, well, unacceptable? Something to ponder.
Definitely.
We'd love to hear what you think. And hey, don't forget to check the description for more details on today's topic. And please subscribe, it's free, to the Architecture Corner newsletter over at architecturecorner.substack.com. Thanks for tuning in.